Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is most profit assigning work. So the problem statement goes like this. You will be having n jobs and m workers. Okay, and then you will be given three arrays: difficulty, profit and worker. So difficulty and profit will represent the difficulty of a particular job and the profit associated with that particular job. Okay, so difficulty and profit will represent the difficulty and profit of a particular job. Okay, and the worker array will represent the capacity of the worker, in which the capacity is the highest difficulty job that a particular worker can complete. Okay, so wo- if worker j jth index of the worker array will represent the ability of the jth worker. That is, the jth worker can only complete with the difficulty at most the value present at the jth index of the worker array. Okay, so that is what I have told you already. And then every worker can be assigned at most one job. So you cannot give more than one job to one worker. That is fine. And again, after that, it mentions that a single job can be assigned to multiple workers. So single job can be assigned multiple times. So for example, let's say there was some job which was paying $1, okay, after completion, and let's say you assigned that job to three workers, then your total profit will be three. Okay, and if there is a worker who is not able to do any job, okay, and difficulties are too much for of every job are too much for him, then in that case, uh, the overall profit will be zero for that worker. Okay, so what you have to return is you have to return the maximum profit we can achieve after assigning jobs to the workers. Okay, so or you can say maximum total profit we have to report or return from the problem statement. So let's have a quick look at the constraints. According to the constraints, the length and profit of the length and profits array, difficulty and profit arrays length will be of order 10 raised to power 4, and same will be the order of length of workers array, which is 10 raised to power 4. Okay, so both difficulty and profits array will be having equal length. Okay, and it is mentioned that the values that there will be in all the three arrays will be of order 10 raised to power 5. Okay, so now without further delay, let's discuss how we can solve this particular problem. We will try to solve it in the most optimal way possible, or at least uh, the solution will be sufficient so that it can pass all the test cases provided the given input constraints. Okay, so we will try to greedily maximize our profit. So we will be using greedy approach because we are told to maximize our profit. That's why we will be becoming a little greedy here. So what we will be doing here is, for each worker we will be trying to find out. Let me write here. For each worker we will try to find out uh, what is the maximum capacity of available job he can do, maximum difficulty job he can do. Okay, Then once we are having those jobs, maximum difficulty basically. So among all the jobs of having difficulty lower than this maximum difficulty or equal to it, we will find the most profitable one for this worker. Okay, then let's say it was max difficulty for current worker. Then for all jobs having difficulty less than or equal to max difficulty, uh, there is a little correction here. Then from all jobs, or you can say among all jobs, we will find the most profitable job. In a way, you can say that we are trying to find the most profitable job for each worker, provided his constraints of his capacity, I mean, of doing the max difficulty job. Okay, so let's say a worker is having capacity of 3, and there are certain certain works available which are requiring certain capacities. Okay, now he is having maximum capacity 3. Now let's say there are 3 jobs available till maximum capacity 3. Okay, so once we are having these kind of capacities, let's say there are some profits associated with them. Let's say it is 5, it is 6, and it is 4. Okay, so these are the profits. Okay, now these profits might be, you know, sorted in a sorted order or might not be in sorted order. So let's say you decide to do the job with the maximum capacity, then it will only provide you for profit for that particular worker. But if you decide to do the job of one difficulty, so these are the difficulties. Okay, difficulties. And okay, so you will get 6 profit. So this is the most optimal job you should be doing. So we will find among all the jobs which are less than or equal to the max difficulty. Let's say this was the max difficulty that a worker could have, difficulty job that a worker could have done. So among all these jobs which are less than or equal to this difficulty, we will find the most profitable one. Okay. So now question arises how we can do so in a optimal way. Okay. So for that what we will be doing here is, just a second. Yeah. So what we will be doing here is, let me take the code so that we can understand the implementation and the approach both in a one go. So let's take a fresh slide. So I think the code is a little bit long. Anyways, we can scroll it. Let's remove this toolbar. Okay. So yeah, I think almost the entire code is visible. So we need not to worry about the code being long. So let's discuss. So what we will be doing here is, first of all, we want to find the maximum difficulty job for each worker. Okay, so for that what we can do here is, first of all, you will be having a difficulty array, and you will be given some profit array. Okay, so there is no single array which is having mappings of difficulty versus profit. Okay, so let's say the first job is giving me some difficulty D, and it is giving me some profit P. So we should be, you know, merging these two arrays, difficulty and profit. Okay, why we are merging them? It will be clear in the implementation part. First of all, you will be forming a difficulty profit array. Okay, so here you will be merging the difficulties and the profits. Okay, so for each, the it will be a 2D array and of size 2. Each entry will be of size 2. The first entry will be the difficulty of the job. The second entry in this difficulty profit array, as the name suggests, the profit is coming after difficulty. So the second entry will be profit. Okay, so what we will be doing here is, we will be sorting this array according to the difficulties. Okay, in ascending order, according to difficulties in ascending order. And you might ask that why we are sorting this array according to difficulties in ascending order. The reason being, for each worker, okay, for each worker, to find maximum difficulty job, or you can say maximum difficulty jobs index in this difficulty profit array, we will be using binary search. Okay, we will use binary search. Those of you who are hearing the name binary search for the very first time, I will you know, try to find a link of this, of an article on binary search. You can explore that article. There you it will be explained that what binary search is, how and when to apply it, what is its basic implementation, and all those things. Okay, so binary, why we are applying binary search, not linear search? Because the overall search complexity, let's say of for n size array, will be log of n. Okay, order of log n. So instead of search complexity for a linear search, we are applying binary search. Okay, so it will save us some time complexity. So there is a constraint for binary search, that in order to apply binary search over some array, it should be the in a sorted order. Okay, so that's why we have sorted this array out. Now proceeding further, and there are further advantages of sorting this array, which we will explore down the line. Then you will be having some array maximum profit. Okay, so what this binary search will give us? So this is the binary search. This function uses binary search. Okay, so this one. So once you are having the index of the maximum difficulty job in this difficulty profit array, then what you will do? First of all, you will check whether that index was -1 or not. If that index was -1, it means that there is no job that the present worker can do. Okay, so if it is not so, the index is not a value which is equal to -1, then there is some job, uh, which at least one job which the present worker can do. Okay, So then the question arises, okay, we have completed the first step. This step we have done. For each worker, we have to find the maximum difficulty job. In a way, we have find out the index of the maximum difficulty job. Okay, we can easily tell what is the maximum difficulty. But here the question arises that how you will find that among all the jobs that were having difficulty less than or equal to the maximum difficulty, what is the maximum profitable job? Okay, so there will be some set of jobs which is having difficulty less than or equal to maximum difficulty. For example, these were those jobs that were having that kind of difficulty. Okay, these were the set of jobs, and there were some profits associated with them. So what we will be doing here is, once we are having this maximum difficulty index, we will maintain one array, which is this array, uh, maximum profit till. Okay, so till each index we will be knowing that, okay, this is the maximum profit we can get. This is the maximum profit job we can do. Okay, and how we will be populating this maximum profit till array uh, is a very interesting thing. We will be using this sorted array of difficulty profit array to populate this maximum profit till. So for each index we will be knowing that, okay, till this index this is the maximum profit you can get. So once you are having that maximum difficulty index, you will use this maximum profit array. Okay, if the index is the very first index, it means it is the zeroth index, then there will be no prior entry in the array before it, so the prior entry contributions will be 0, and you will be just taking the current profit, okay, in the difficulty profit array. And if there is some prior entry in the maximum profit till array, then you will taking that maximum of these two. Okay, these two. Okay, so in a way you are doing something like this. Let's say there were some entries 3, 5, and then 2, 4. Okay, so if you want to find what is the maximum profit till now, let's say these are the indices. So it is 1 and there was no prior entry, then you will do comparison between these two, it will result into 3. Then you will comparison between these two, it will result into 5. Then doing comparison between these two, it will result into again 5. Then comparison between these two, and it will result again into 5. So this is what we are doing here. Okay, so once we are done with it, we will be having our maximum profit till array, and binary search will give us maximum difficulty index. And simply we will add the current profits to the total profit, and we will be returning it. Now question arises that how we will be implementing this binary search. Okay, so what we are doing here is, we are here kind of finding out kind of upper bound. Okay, so the maximum range till which we can go. So what we are doing here is, so what will be the search space for our binary search? The search space will be from the 0th index to the last index of the difficulty profit array, and this will be the worker capacity that we have to find the maximum difficult job for. Okay, so this is a standard binary search here. The only difference is between the standard and the little bit tweaked one is the way we are, reducing the search space. So let's say from between left and right indices or left and right bounds, you find out some middle bound or middle point in the binary search through this step, which is the standard binary search. Then this point is less than, the difficulty at this point is uh, less than or equal to the worker capacity. In that way you can say that okay, this job can be done by the worker, so we might be interested in searching for some higher difficulty jobs. Okay, let's push the boundaries to uh, somewhat higher range, so that uh, we can test the boundaries of the jobs which are available or which are reaching till the maximum capacity of the worker. So in that way we are trying to shift our left boundary to one position beyond this midpoint. Okay, so that is what we are doing here. And before shifting the left boundary to one position beyond midpoint, we are uh, storing that midpoint in our answer index. Okay, so by default it is having -1. -1 indicates that we were not able to find out any job for the current worker. Okay, so this is one case. Now let's discuss another case, that this midpoint job is having higher difficulty than the maximum capacity of the worker. So in that case you might be wanting to look for jobs with lesser difficulty, so you will be shifting your right bound to just one point before midpoint. Okay, so in that way your search space will again reduce. So these are the ways in which we are reducing the search space in binary search, and this is the whole implementation. And if we talk about what will be the time complexity, so because of use of this sorting, and let's say the difficulty and profit array were having size n. Let me take it to another board. Let's say difficulty array was having size n. So because of use of sorting, the time complexity will be n log n. Okay, and as per you know as far as this is concerned, this particular loop, this will also add some complexity. Let's say the size of the workers array was n. Okay, not n, m. So in a way, you know this will take the complexity of m into, so this is just a binary search applied over n size array, m into log of n. Okay, and since the maximum boundaries of m and n, or the sizes of the difficulty array and the workers array was same, so the overall time complexity will still be order of n log n. Okay, so you can see in the constraints it was mentioned that both of the ranges were having same upper bound, or the sizes you can say were having same upper bound. That's why overall time complexity is order of n log n. Now let's discuss about space complexity. Since we are using two arrays, one is a 2D array, so it is of size, let's say n, it is n into 2. Okay, and the second array, the max profit till array, is also having size order of n. So in all you can say that the time complexity is order of n. So these are the complexities, and this is the whole approach. Okay, so we are using binary search to find maximum difficulty jobs index in this sorted array, which is difficulty profit array. Okay, and then once we are having a set of jobs which the worker can pick according to the maximum available profit, so this kind of set of jobs will be available to each worker, kind of options available to each worker. Okay, each of the job will be either having the capacity less than the maximum capacity of the worker or equal to the capacity of the worker. The worker will pick among these jobs. Which job he will pick? he will become a little bit greedy here. He will be picking the maximum profit job. Okay, so just like here, he although the maximum difficulty job that the worker could have accomplished was this 3, but he picked this job 1, which was having the maximum profit. So this will be done with the help of maximum profit till array. So this is the whole logic and approach. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I hope this solution walkthrough added some value to your DSA journey of honing your DSA skills. Until then, keep solving problems and keep practicing. I will see you in the next video. Thank you for watching.